Hello everyone and welcome back to the ThermoXAV channel. I'm really excited to bring you a new tutorial today focused on thermodynamic phase determination of water in EES or Engineering Equation Solver software. The problem that we are going to solve it today is determination of thermodynamic phase of the water at the following conditions: pressure 75 kilopascal and the temperature of 85 degrees Celsius. After determination of the phase of the water at the specified pressure and temperature, we are going to identify whether this water is located in the pressure or subcooled liquid region, saturated region, or superheated vapor region. Previous session and tutorial, we went through these two property diagrams, TV and PV diagram, and we discussed regarding all these regions and lines. So these two useful property diagrams, as you can see, consist of three major regions: compressed or subcooled liquid region, saturated region, and superheated vapor regions, as you can see. We have two major lines: saturated liquid line and the vapor line, as you can see in this graph. And for TV diagram, we have some constant pressure constant lines like P2 and P1, and this P2 is always greater than the P1. The same in the PV diagram, we have a temperature constant lines like T2 and T1 in this example, and T2 is always greater than T1. So according to this information, we can always identify if liquid, if a substance or refrigerant is in which of these regions. To find out this actually region, the thing is, the first step is to identify actually identify if this pressure and temperature depends on each other or not. If it is depends on each other, so they are in the saturated liquid vapor region or on these two liquid and vapor lines. Otherwise, they are not actually dependent on each other. So we will determine for this problem today. So we can simply go to the saturated water table at the thermodynamic reference and find out the saturated pressure for this temperature. If it is equal to 75 kilopascal, so then we can identify that this working fluid water is located in one of these regions: saturated liquid, vapor, or a mixture of liquid and vapor. Otherwise, it will be on the compressed subcooled liquid or the superheated vapor. So I will go through one saturated water table, and here you can see this temperature 85 degrees Celsius is located. And as this is for saturated water, we can see the saturated pressure for this temperature, which is 57.87 kilopascal. So because for this temperature, pressure is 57.8 and it is not equal to this 75. So this the phase of this water in these conditions is not in the saturated region. So we need to find out if it is in the subcooled region or superheated vapor region. To do so, we can simply use the EES software. Okay, so first of all, I'm going to write it down. The input of this problem, P1 is 75 kilopascal, equal to 75 kilopascal. And then T1 is equal to 85 degrees Celsius. You can simply go here to the first thing is you can check your units here as a default. EES consider the temperature Celsius for the temperature units and kilopascal for the pressure units, which is the same as the conditions that we are going to use and solve this problem. So we don't need to change this default value. So then after that, I'm going to define the unit for this P1 and T1. To do so, you can just simply go here to the variable information, click on it, and then here you can define the unit. For the pressure, it is kilopascal, so you can click and then right click and find out your correct unit. Here it is kilopascal, so I will paste here, and then for the temperature, right click, then I can select the Celsius here and paste here. Then I can press OK. So after solving this problem, the unit will be shown here in the solution window, as you can see. So here it's kilopascal and then it says Celsius here. So then the first step is find it out the saturated pressure for this temperature. To do so, I will go to the next line, and then here we have access to the function information window. We will go there and then change this one, the option, to the thermophysical properties. I will select this one. Here you can simply find out your refrigerant or substance. I will select water. And then here in this list you can find out different variable and functions. So I will go down and find and search for the saturated pressure. Saturated pressure defined like this, P underline SAT, kilopascal. Then I will select here, and then if you press on the paste, so this sentence actually will be pasted here in the equation window. So this equation will be pasted here, and you can use exactly like here. So I will press on the paste, and as you can see, there is only one variable T to find out the saturated pressure, because this temperature and pressure in the saturated region are dependent to each other. So I will press paste, and then so you have a new variable P underscore SAT, or saturated pressure, and to find out this value you need to put one input here. You can just simply write it this 85 like here, or you can use this input variable that you have, which is T1. So this function will identify the input value for this function is this one, T1. And here also you can go and change this saturated pressure unit by clicking here and changing to kilopascal. But I just skip this step now, and then after solving I can show you, and I update this one. So I will now press on the solve button, and as you can see, the saturated pressure is 57.87 kilopascal. So here, as you can see, you can actually solve this one by going again here, and then right click and select kilopascal, paste, and then OK. So after solving again, there's no problem for these units here. And so as you can see, this saturated pressure is 57.87, which is less than this pressure for our problem. So now we need to go to the property diagram and find it out. So in EES software, there is an option very useful to work with that, and that's a property plot. So you can just simply click on this property plot, and then there are lots of options to choose. Different type of plot, like this TV, TS, PV diagram. I will select this TV diagram, and then at the end of the list, I can find it out, the water. And then here, these are the constant lines for the entropy, so I don't need those ones, so I can just simply click here and disable those ones. And then I need to define two pressure constant lines, one for this saturated pressure and one for this working fluid pressure, 75. So I can just disable all, and then select this one, and write 75. And for this one, I can write it down 57.87. And then here as a default, this show constant line is checked, but you can uncheck this one. Then actually you are disabling this one. And then for this constant pressure, I will change the color to the red color and then press on OK. So now I have this TV property diagram, and then I can adjust this window a little bit by drag and drop. You can simply select and then move these labels here and work with that. So these are two pressure constant lines, one for this 75 and one for this 57. So I can keep it here for now. And then here you can simply modify this plot. For example, by double clicking here, I'm going to change this 57 to another color, like for example this green one, and then use another type of line and use some symbol like for example this circle here. Then for this one also I can change the line thickness and then use some symbol simply like this, and then press on OK. Then you can also I'm going to focus a little bit more on this area, because this 75 pressure here and temperature is also here, this working temperature 85. So I can zoom a little bit here. To zoom out, you can change the axis. For example, go to the plot and modify axis. Then for the x-axis, I can extend a little bit this line. So I can change it to E-5, for example. And then I can also activate this grid line for the x-axis. Then for the y-axis, I will go here and change this 700 to like 200. Activate the grid line and then press on OK. Here you can activate the minor grid line as well. So for now I can activate like this, but it seems these vertical lines are not necessary. I will go back again to the modify axis, disable this one, just keep this one. And let me check modify axis to go to the y-axis to activate this minor grid lines. So here also you can also go again here, and for this y-axis, so as you can see, this is maximum and minimum. You can just change it to 10. So these are changing to like this 80, for example. The interval will be changed to 10. So now actually, as you know, I can modify this one again and also change this color to green. And as you know, this pressure constant line is related to the temperature of 85. So here is 85 degrees Celsius. So if you are going to add one line here, for example, you can simply use some line tool, or you can define actually a line and actually overlay another plot here. So to do so, I'm going to just create a straight line on the 85 degrees Celsius. So it will be this line till here. And so I can define 2 points, one point here, 85 and 10e-5, and one here, 85 and 50. So I can go to the tables, select a new lookup table here, and then instead of 20 rows, I will select 2 and then press OK. Then I can extend a little bit this one. So for the first column, which is this X, I will select like this one, 1e-5. And for this point is related to the X, And so I will select this one 50. And for this column 2, which is related to the y, it is 85 both. So now we have a line with 2 points. One point is this one, and one point is row 2. So now when you fill out this lookup table, so this option will be activate overlay plot, and you can overlay this plot into another plot. So I will select this overlay plot here, and then define the new line here. So first I will select for the x-axis, I will select column 1, which is this one, and for the y-axis I will select column 2. And then you can change the color and then press OK. So I have this constant line here. And then I can just simply create one line, is something like that. For this constant constant pressure line, I can just double click here and then go to properties, change the color to red, for example, and then change the thickness like that. Now I can also create one line for this one, for this constant temperature, change the color to green, and then change this one. So now it is something like this property plot like that, with this constant lines. As you can see, these two I created manually here. So now we can discuss about this one, if it is in the subcooled region or in the superheated region. So for our problem, temperature is 85, so we have to be on this line anyway, and the pressure is 75 kilopascal. So this line is for 75 kilopascal. So here, if you go through this line, the temperature is higher than 85. Here also greater than 85. But the pressure is always 75 when you are in this red line. And when you reach here, the pressure is 75 and temperature reach to 85 degrees Celsius. So this is the region that we are in. So I can just simply create a area here. And then, so we can understand that in this area, this is the subcooled area. So I can just write it down. And then press OK. So this region is this point is the subcooled area. Region is subcooled area, and this point is located in this subcooled region. So we can simply identify from our problem that this point is located in the subcooled region. So very simple, you can understand and then identify the phase determination. And then if you go here, you can simply calculate any property or variable of this water in these two conditions. So you can just simply again go here to the function information for the water, thermodynamic, thermophysical properties. And for example, enthalpy, you can find out here, enthalpy, kilojoule per kg. So you can select this one. And as you can see, you need two input in this in this subcooled area. So you can simply press on paste and then here change this one to T1 and P1 and then solve the problem. Then here this enthalpy is 356 kilojoule per kilogram or kg. So here also you can go and update this H by right click and then find out here in this unit area, paste and press OK and solve one more time. Then you can have this unit also for the enthalpy. So that's it for today, and I hope to see you in the next tutorial of thermodynamics and EES software. Thanks for watching.